Medicine is changing. Procedures performed just 5 years ago are already antiquated. More and more minimally invasive procedures are becoming commonplace, and advanced imaging modalities now let clinicians see inside the human body with amazing clarity while localizing human anatomy with positional sensors. Rapid advancements are also being made in instrument guidance. Locating medical instruments in 3D space is a key requirement for many emerging procedures, especially image-guided ones. To meet this need, Ascension Technology has developed a new generation of pulsed DC magnetic tracking technologies and proprietary techniques for medical procedures. These DC magnetic devices are built upon Ascension's 2 decades of expertise in developing advanced magnetic tracking technologies for virtual reality, simulation, and computer animation. When our 3D measurements are combined with imaging modalities, clinicians can instantly and precisely locate and guide medical instruments to an exact target, whether inside or outside the human body. Prominent uses include real-time navigation of flexible instruments from scopes to catheters, guidance of surgical probes and biopsy needles, precise placement of surgical implants, 3D tracking of instrument tips for simulation and training, and localization of ultrasound scan head planes for 3D reconstruction of anatomical objects. Here's how this remarkable 3D localization technology works. A small transmitter placed near the patient generates a series of pulsed DC magnetic fields. The fields induce measurable voltage changes in one or more miniaturized sensors, typically attached to a body part and/or instrument. As the sensor moves through space, field changes are recorded and reported to an electronics unit. These data points enable the calculation of the real-time position and orientation of the sensor in free space. Up to 375 measurements are made per second with high accuracy and resolution. Today, our 3rd-generation DC tracking technology represents the state-of-the-art in tracking medical instruments. Besides holding landmark proprietary status, it precedes and leapfrogs competitive AC magnetic tracking technologies in speed, accuracy, and immunity to distortions. DC tracking technology offers superior results when compared to AC electromagnetic systems. First developed in the 1970s, AC tracking systems continuously generate eddy currents in nearby metals. These AC effects distort the accuracy of measurements and cannot be compensated for in real time. In general, DC trackers exhibit 1/5 the sensitivity to nearby conductive metals as AC systems. DC technology also has the exclusive capability to readily adjust its measurement rate, meaning the system can drive many conductive metal errors to 0. Ascension's latest medical tracker, 3D Guidance, includes micro-miniaturized sensors and transmitters developed specifically for surgical navigation. 3D Guidance sensors are presently 1.3 millimeters in diameter, and 0.3 millimeter sensors are now operational. Transmitter options include the mid-range transmitter for accurate tracking over ranges up to 1 meter. The short-range transmitter, a lightweight field generator that can be brought very close to the patient. Small and unobtrusive, it can be draped while in the sterile field and still deliver clear field signals to its sensors. And the flat transmitter. This breakthrough design overcomes ferrous metals often found in common medical procedure tables. Its built-in shield blocks all interfering metals below its surface while accurately tracking sensors inside or above the human body. 3D guidance sensors are small enough to fit into the tips of many instruments, as well as the working channels of scopes. Its sensors are often incorporated into catheters, probes, interventional devices, and flexible endoscopes. Emerging minimally invasive medical procedures are wide and varied. A few applications that are already in use or that are being investigated are interbody navigation, computer-assisted procedures, RF ablation, image-guided intervention and delivery of therapy, 3D ultrasound, electrophysiology, brachytherapy, telerobotics, and telesurgery. One of Ascension's partners, 1medical, is presently testing a new obstetrical product, Labor Pro, designed to reduce the risks in childbirth, improve outcomes, and lower the cost of obstetrical care. At the start of labor, a computerized pelvimetry is performed with radiation-free magnetic sensors. Ultrasound, aligned with a position sensor, then scans the fetal head. Known landmarks are identified, and the Labor Pro system determines the spatial position of the fetal head in relation to the mother's pelvis. Employing Trig's computerized finger, a one-step, accurate, and objective assessment of fetal head station and cervical dilation is carried out. For continuous monitoring of fetal descent and cervical dilation, position sensors are attached to the fetal scalp and the maternal cervix. From this point forward, vital information for good decision-making is instantly presented to the obstetrical team. Medical procedures require a close integration between tracking and advanced imaging modalities, and Ascension is strategically aligned with leading medical research institutes. Our commitment to developing innovative tracking solutions for minimally invasive procedures is well recognized in the medical community and by our peers. 3D Guidance has been named one of the top 100 new products of the year by R&D magazine and is the recipient of a Frost & Sullivan Technology Innovation Award. Our understanding of 3D tracking for medical imaging is backed by over 100 man-years of engineering, designing, and developing tracking devices. We have the knowledge, the team, the experience, and the flexibility to turn your vision into a reality. Let a partnership with Ascension help you lead the medical revolution in image-guided procedures.